Hello, everyone, and welcome back to the Cisco Optics Podcast, where we talk about pluggable optics for networks. Single-mode fiber transformed telecommunications in the 1970s and 1980s by raising the ceiling for communication bandwidth over transoceanic distances. It took years of R&D to get there, though. Remember, we're sending light through tens of kilometers of glass without regeneration. I mean, imagine how pure the glass of an 80-kilometer thick window needs to be in order to see through it. This is episode 48, and we continue our conversation with Roisin McCool, expert in fiber networks for telecommunications and scientific instrumentation at Corning Optical Communications. We continue with fiber density and bend resilience. Roisin McCool is a senior market and technology development manager for Corning Optical Fiber and Cable, specializing in single-mode fiber and access networks. She provides technical and market insight for Corning's global fiber and cable product line management teams. Roisin has 30 years of experience in engineering and optical communication systems and subsystems, including many years designing networks for advanced radio telescopes. Roisin has held project management and coordination lead roles in diverse teams throughout her career. Roisin is the acting chair of the Women in Fiber Committee for the FTTH Council Europe and is the winner of the Corning Optical Communications You Make a Difference Award 2022 for her leadership of diversity initiatives in Corning. Roisin holds a master's degree in electrical and electronic engineering from the University of Nottingham, United Kingdom, and is a chartered member of the Institute of Engineering and Technology. And now join me as I talk with Roisin McCool.
When it's in highly dense cables, we can still maintain the low loss that we expect from single mode fibers.
Okay, let me see if I can unpack this. So the fiber itself, you don't want to change the properties compared to the standard single mode fiber. So you reduce the outer diameter, and that allows for more space.
We do both.
Oh, okay.
So we create a bend resilient fiber. Mm-hmm. And we reduce its outer diameter. And then you have a fiber which is ideal for dense cables because it's more resilient to the microbend, and also you're reducing the amount of space it's taking up in the cable.
So when you reduce the outer diameter, are you maintaining the density of the cable and filling up that extra space with some soft buffer material or something?
No, it allows us to go smaller. It allows us to get a lower outer diameter cable.
Ah, okay.
Yeah.
Okay, so same number of fibers in the cable, but the overall cable diameter is also reduced as you reduce the fiber outer diameter.
I need to say this, which is really what is the definition of density. Why would you need density, right?
Okay.
So density means two things in practice in cables. First of all, it means you can have more fibers in the same outer diameter cable. That's one thing you can do. You can take the cable that you use today and for the same outer diameter get more fibers in it. The other definition of density is that you can take the same fiber count and make a smaller cable. And that could be important if you're trying to drop down a duct size. So if you're trying to extend out into the network, and maybe as you extend out into the networks, the ducts get smaller, but you want to put the same amount of fiber in, well, that all density helps with that as well.
Okay, so there are two ways. Those are the two categories of ways to increase your density.
Yeah, and it's doing the same thing. You're basically getting more fibers per millimeter squared.
Okay.
But to do that, you need these fibers that have this bend resilience and low outer diameter.
Right. Okay. So you're doing it with both approaches, the actual glass design,
Yep.
and then the dimensions of the.
Yeah.
of the fiber.
Yeah.
So how has this been? So what kind of impact have you seen because of this increased density? What do you see any? Is this widely deployed now? Is this a common practice? Or is it taking off at this point? How new is this?
It's a trend that's been increasing over the years. I've seen it increasing. So it definitely is getting more traction, and it is being installed both in the US and in EMEA as well. The very, very highest density cables that Corning sell are our mini extend cables, and it has an impact on the installation schemes because they are cables that are installed in subducts. So there are advantages with that in terms of speed of installation, because you can blow the cables through these subducts. But we do have like really highly dense cables that are pulled in the way that, traditional cables are, that are pulled on a rope through duct. And I think I would say, I cannot think, I'm sure there are applications, but off the top of my head, I can't think of many applications where we're not trying to get more fibers in the same duct size, or the same amount of fibers in a smaller duct size. I think I mean, obviously on the drop cables and stuff like that, that's an obvious place where that's not necessarily changing, but everything is miniaturizing now. And it's associated with density, but also about sustainability as well, because you're using less materials. The smaller the cables are, the less transport costs there is, the easier they are to handle, all of that matters.
Okay, I didn't think of that. So I mean, we think of these cables as being very small, but they can be really, really long, right? And so it's actually quite a bit of material once you accumulate over these distances.
Yeah, exactly. And of course, everybody's concerned about transport and, the impact that we're having, the sort of carbon footprint that our products have, and that the installation has, etc.
So this is a trend. Are there any other trends that are happening right now in fiber?
I think so. One of the trends that I think that we're seeing, aside from density, is this proliferation of endpoints. So what do I mean by that? Well, we're seeing more and more things getting connected to fiber. More homes being connected directly to fiber, but also the trend on, 5G. So one of the really interesting things about fiber is that in the mobile networks, they're actually, because of 5G and because of the increase in bandwidth, those networks are becoming fiber connected, right? So we see a lot of fiber going into those mobile networks. And then, of course, with the Internet of Things, whilst not all of those things are being connected by fiber, they're all going onto wireless mobile networks, and that data is then being transmitted by fiber. So, I mean, I think people would be quite astounded by the amount of fiber that's in their mobile networks. And that then has to go somewhere. And of course, that goes into the data centers. And aspects of data center location, like latency, like just the physical size of things and the amount of power that is required. That means those data centers are kind of distributed a little bit more. So I would say that is you've heard of the edge data center. I'm not sure we're quite there yet, but there's certainly more of a distribution. And then in long haul networks, those capacities are just really, really going up. And as we're talking about the future, I guess we should talk about some of the future fibers.
Yeah, a couple come to mind, but I'll let you name them.
So there are some really exciting developments on kind of almost fundamentally changing the fiber, if you like. So right now, I've been talking about fiber counts in cables, but in the future, we might be talking about the number of cores in cables, because there are multi-core fibers that are they're a focus of research, I would say, in which you have the normal fiber, so the standard fiber, but within that fiber, you've got 4 or 8 or 2, however many cores within that fiber. So you're multiplying the number of transmission pathways in a single fiber, and that's called multi-core fiber. And that's a really active area of research right now.
So whereas the current standard is a single core fiber with one core in the center, and now you're saying in the same cladding, instead you have multiple cores, and they're just consuming more cross-sectional space within the cladding. So this sounds like the ultimate in density then.
Indeed. Well, you can multiply the density by the number of cores that you can fit into the fiber. Yeah.
So what are the current challenges that are being tackled right now with multi-core?
I think there are a number of challenges. Obviously, there's just the sheer challenge of making a fiber like that, right? Of making sure that those cores are aligned, that they're consistent, that the manufacturing thresholds and variances are within tolerance. But the other aspect of it is the ecosystem. So the ability to take that fiber and connect it to something, right? If you think about, Cisco, me, the Corning lady, arrives at Cisco, and you, the Cisco guy, have 2 receivers, and you want to plug it into my multi-core fiber. Well, you need 2 cores, right? And I've only got 1 multi-core fiber, so
you gotta somehow get the light from the fiber into the transceiver,
so,
and vice versa.
So that's right now. That's using components called fan outs, and so that whole ecosystem on how you connect to multi-core fibers needs to develop. How you splice multi-core fibers, how you amplify multi-core fibers. All of that has to be worked through, and of course, developing ecosystems takes time. I think one of the things that has been an area of research is if you put multiple cores into a fiber, what happens to the light in that fiber, and how does it interact with each other? So how far away do the cores have to be from one another in order that you don't get negative impact on the transmission? That's an
Kind of
example of
crosstalk
that.
or
So, and what is the best profile to put in those fibers? So all of that, I think, that's an area of active research, and I think it's got to be worked out.
okay. Do you know if people are working on like any mechanical issues? Just like mechanical. That was the 5th part of my conversation with Roisin McCool. Next time, we'll get into mechanical considerations and the quality architecture of fiber manufacturing. Hey, we have a new website. It's optics.podcastpage.io. That's optics.podcastpage.io. You can either listen there or use the same podcast platform you've been using all along. Please subscribe. Better yet, leave a review, especially if you use Apple Podcasts. Remember, we're part of the Cisco Podcast Network, where you can find other great Cisco podcasts too. We also have educational videos on YouTube. Just go to youtube.com and search on Cisco Optics. Thank you for listening. This is Pat Chow, Product Manager at Cisco Optics. The next episode is part 6 of my conversation with Roisin McCool. Until next time.